What's machine learning? By NextBrain. Machine learning is a subset of artificial intelligence in which a computer learns something without being explicitly programmed. This means that we don't ask the machine to make a specific calculation. Instead, we ask the machine to read data, learn from it, and then make a prediction. Machine learning algorithms looks for patterns in data. Patterns are regular repetitions in data and are very useful to understand it. If we consider data to be a sort of information, then algorithms could be something like information readers. In mathematics, data is represented in templates. These templates are also called objects. We can represent the same data with different templates, and all of them will be equivalent. Each mathematical field uses specific templates. For example, in statistics, data is defined as probability distributions, and in geometry, as data spaces. In machine learning, we are going to use a fundamental principle in mathematics. We can learn a lot about a mathematical object by studying its interactions with other mathematical objects. For example, if we want to discover patterns in our data, but we can't see them easily, we can make this data interact with other data. The result of this interaction will be another mathematical object, where it could be possible to identify patterns more easily. There are several algorithms using this principle for learning data. There are two types of machine learning algorithms: supervised learning and unsupervised learning. Supervised learning algorithms uses a subset of the data as a reference to understand the remaining data. The term dependent variable in statistics refers to data that has been separated as a reference. The goal of supervised learning is to train an algorithm to predict this dependent variable from the rest of the data. In supervised learning, the dependent variable, also written y, is a function of the rest of data, x. A function is a way to describe how y is related to x. A function is also a mathematical object. When we use statistics for machine learning, we are mainly interested in data interpretation. We use data probabilities to make this analysis. Statistics consider all variables to be random, so are considered as probability distributions. When we are using statistics in machine learning, we can talk about statistics learning. Statistics learning is about finding boundaries in data. Boundaries allows us to divide data in different classes in order to find patterns. A probability space is a set that represents all probability values of a variable. The range of this space are the different probability outcomes a variable can have. A variable and its prediction can represent different probability spaces. This difference will help us to calculate the accuracy of a model. Once we have trained an algorithm, we want to know if we have done it right. This is why we need to measure its accuracy. Accuracy is a measure of how many values of a variable we have predicted correctly. We have seen before how data is organized in templates, and that these templates are equivalent when represent the same data. In geometry, data can be represented in shapes, like lines, squares, cubes, or with any other shape. In mathematics, these shapes can be described by an equation. This equation is, as well, a mathematical object and is equivalent to these shapes. Finding patterns in data using geometry can be very intuitive. Imagine that we have some data and that we can represent this data in a two-dimensional space, a plane. If we want to classify data in two classes, we can take this plane and start folding the plane until we see that these classes falls in different sides of our fold. Another important theoretical framework used in machine learning is information theory. In this theory, data is seen as information. For example, a dataset contains some information. And when we try to predict a variable, we have to keep this information, not lose it. We can see this as a measure of how well we are doing with our model. So we are going to tell the algorithm to find a solution for our problem, but without losing information from the original data. Information theory also will help us to deal with a very important concept in machine learning: uncertainty. As usually things are not black or white, dealing with uncertainty will bring us to a better understanding of our data. We have already seen supervised learning, where we have a reference variable or dependent variable. In unsupervised learning, we have not a reference variable. Algorithm cannot learn from data with a reference. In machine learning, we also call this reference variable label. Unsupervised learning will use unlabeled data. But then how and what the algorithm learns? The answer is that algorithm will look for similarities in data and will group data according its closeness. Data points close or similar to other data points will be grouped together. For example, imagine we have a group of people and we want to classify them. In supervised learning, we will classify this group from a reference variable, for example, hair color. We will classify people in 4 groups, with black color, brown, red, or bold. Unsupervised learning will group people according how similar they are, according the algorithm's similarity criteria. The most important step for the algorithm is its last one, the evaluation. In this step, the algorithm will check how good have performed its task by comparing its results with the reference variable. This step is called the optimization step. The algorithm will repeat, again and again, its calculations if, in this step, is measuring a difference between its results and the reference values until this difference is close to 0. This is the process by which an algorithm learns. We have already classified machine learning problems in supervised and unsupervised. Supervised learning problems are mainly represented by 2 algorithm types: classification and regression. Classification problem's goal is to predict a target variable, or label, from the rest of variables. When this target variable is a binary 1, for example, black or white, yes or no, and 0 or 1, then we are talking about a binary classification problem. When the target variable has more than 2 classes, then we call this a multi-class classification problem. For example, when we want to classify a group of people by its hair color, our target variable has 4 options: black, brown, red, and blonde. This is a multi-class classification problem. In a regression problem, we are interested in predict a continuous variable. For example, we want to predict age that has values from 0 to 99 years. Or height with possible values from 150 to 199 centimeters. In regression problems, we understand 2 different standards: univariate regression and multivariate regression. When we want to predict our target variable from another single variable, we have a univariate regression problem. If we want to predict our target variable from several variables, we have a multivariate regression problem. A special case of univariate regression problem is what is called time series forecasting. In this problem, we want to predict a target variable from another variable that is a time series. A time series variable can be, for example, days, or weeks, or months, or even hours or minutes. For example, we have registered the rainfall during last year at daily basis in our county. We have recorded the rainfall in millimeters each day and we have written it in a spreadsheet with 2 columns. In the first column, we write the days, with the format, day, month, and year. In the second column, we write the rainfall values. Our problem lies in predict, which will be the rainfall values on next year, based on what have registered from the previous year. To solve a time series forecasting problem could sound something like magic, because we are predicting the future. But algorithms can learn very complex time patterns and amaze us with very accurate predictions. However, we will always have uncertainty in our predictions. Then, the question will be, to get a prediction with the lowest possible uncertainty value? Finally, in unsupervised learning, as we have already seen, we have a data grouping process. These groups are also known as clusters, and the algorithms doing it as clustering algorithms. These algorithms could be difficult to explain because the resulting groups or clusters are not obvious. But at the same time, can be very powerful because they can find complex groups that can be very useful to deep understand our data.